definitely say that yesterday was the hardest lesson of the year, okay? Shh. If you understood yesterday's lesson, hooray for you, that is great. If you're still confused by it, that's really normal, okay? You can watch the video again, go over the notes. We'll be practicing different types, but it's actually easier from here. Okay, today and tomorrow you're going to think are pretty easy, I think. And then, so today we have what we're doing today is sum and difference formulas, and then tomorrow we're doing double angle formulas. Okay, so anything that says day 3 is today, day 4 is tomorrow. So we'll be in the same notes at the beginning of class tomorrow. So like I said, we're doing some really small little bites. Friday you'll have a sub and a worksheet to do. That's a review of trig. If you know you're not going to be here on Friday, I'll offer the worksheet to you tomorrow so you can have it early if you want. When we come back from spring break, that Monday, we have one last new lesson. Tuesday is a work day, so Tuesday after spring break is just getting caught up, asking me for help on any problems, and then Wednesday is that open note quiz. So 2 weeks from today, open notes. Okay? All right, so let us get started. So let me tell you about the sum and difference formulas first, and then I'll tell you what we use them for, okay? Sum and difference formulas are addition and subtraction for both sine and cosine. So what I want you guys to do is really stay with me right now and help yourself learn the patterns, because you have to actually know the sum and difference formulas. They're really easy, believe it or not. Guys, please don't talk. Believe it or not, you will 100%, if you pay attention to me, you'll know these by heart maybe by the end of the paper. Okay, they look really confusing, but they're actually really not. What I want you to notice is that you have sine, a sum formula for sine, a difference formula for sine, a sum formula for cosine, and a difference formula for cosine. Okay? And what you have in every set of parentheses in the same order is an A and a B. That's the alpha and beta of the Greek alphabet, alpha and beta. And notice it's always in that order, A, B, and so on. It's also in that order the same in all 4 equations. Alpha, beta, after whatever the sign is, we'll talk about that in a minute, alpha, beta. Look, A, B, A, B, A, B, A, B, A, B, A, B. Also, every time you go to the other side of the equal sign, how you start the problem is whatever's written here. So sine alpha is what happens first. Sine alpha happens first, right? Cosine alpha, cosine alpha, cosine alpha, cosine alpha. Here's some other things that are going to help you. Notice on the sine formulas, the sign stays the same. Plus, plus, minus, minus. The word sine starts with an S, so does same. Okay, so for sine, the sign, S-I-G-N's, are the same. And luckily, cosine starts with a C, which also is change. So cosine's sum formula, when you expand it, has a different sign, subtraction. So change from plus to minus, from minus to plus. So remember S and C to help you with that. Then it's the order of the words, okay? So some people can respond to this, SCCS. It's sine, cosine, sine, cosine, cosine, sine, sine, cosine, cosine, sine for those, and CCSS for these. But I have another word to help you know the order of these, and that is the word social, which starts with an S. Sine is social, meaning sine will mix with other people. Sine will hang out with cosine, right? But cosine is not social. I don't have a word for that. Some people say crazy for C. They only hang out with their own kind. So if you know that sine is social, they hang out with other people, then cosine only hangs out with itself. Cosine, cosine, so all that's left over here is sine, sine. I'll go over that with you again as we do our first problem, okay? So between these 2 problems, we'll go over those little patterns again, and I think you guys will have it. But this is an open note quiz, so you might be thinking, why is she telling me I have to know these? Clearly you don't have to know them for the quiz, but when it comes to the AP exam, I know there was at least one multiple choice question that had these on it, so you do want to know them. So I'm just challenging you giving you the good idea of as you work on these, try not to depend on these. It'll help you just memorize them. Okay? All right. So let's talk about what they're for. When I taught you guys the unit circle and I made you do all those like trig quizzes, those were finding exact values. Do you remember the directions said find the exact value of each angle? So for example, I would have said, what is sine of pi over 6? What's the exact value of sine of pi over 6? It is 1/2. What is the exact value of tan of pi over 2? The exact value of tan of pi over 2 would be undefined. Okay, those numbers that you wrote on your answer sheet, those are called the exact values. They're exact. They have a radical in them a lot of times. We didn't round them. Because I could put cosine of pi over 6 in my calculator, but it's not going to spit out square root of 3 over 2. It's going to give me a decimal. Okay, that's not exact. These are exact. So what do we do if they say, what's the exact value of sine of 5 pi over 12? You'd be like, my teacher didn't make me memorize that one. I have no idea. That's what sum and difference formulas, and then tomorrow double angle formulas are for, is to find exact values of non-standard angles. So what we do is we come up with two angles that add up to get the 5 pi over 12. You come up with two angles, and I'll show you how easy it is. You come up with two angles that when you add them together equal 5 pi over 12. You can use any two angles on the unit circle. And by the way, you can add or subtract. You might have like a really big angle in quadrant 4 that you subtract from an angle in quadrant 2, which gives you whatever they're asking for. But most of the time, we just stick with quadrant 1 angles because they're the easiest. Guys, pay attention. So where did they get the 6 and the 4? Okay, so just understand, if you have a denominator in the 6 and a denominator 4, how can you figure out the denominator of 12? This has kind of worried me in first and second period. I felt like there were people that did not know how to find a common denominator. We've been doing that in this class. We did it yesterday. Okay, you should be able to look at these two angles and say, okay, whether you do it in your head or not, I wouldn't be surprised if you could do it in your head, but you should at least be able to write it out. 6 times 2 is 12, so I multiply the numerator by 2. 4 times 3 is 12, multiply the numerator by 3. And when you add those two together, you get 5 pi over 12. So that's where they got these two angles, okay? So what we're going to do is label them always in this order, alpha, beta. And so what we have is sine of pi over 6 plus pi over 4, right? We have sine of pi over 6 plus pi over 4. So we're going to expand this according to the formula up there. But let's try not to use it, right? We call this alpha, this beta. The way we always start is what you see first. So it's going to be sine of pi over 6 times. Sine is social, so he mixes with cosine. And we always do alpha, beta in that order. We're doing a sine problem. Sine means same. This is a plus. Make this a plus. Now, the only place that I could think of that you could mess this up if you know all my tricks is right here. Okay, how do you know if you put sine or cosine first? Well, one thing you do know for sure is that the angles have to be in this order. Pi over 6, pi over 4. So I have to have pi over 6, then pi over 4. And you shouldn't have any repeats. I will not have two of the same exact value requests here. I'm not going to have another sine of pi over 6. So I have to do cosine of pi over 6. That helped me know not to put sine there, because I wouldn't have a double of the same problem. And then that just leaves sine of pi over 4. So that's the expanding of it. And now you use your unit circle knowledge, and you simplify this. So sine of pi over 6 is 1/2. Cosine of pi over 4 is the square root of 2 over 2. Plus, cosine of pi over 6 is square root of 3 over 2. And sine of pi over 4 is square root of 2 over 2. And now I just simplify this one step further, and I'm done. Remember, when you multiply fractions, you don't need a common denominator. You don't. This would be square root of 2 over what? What's in the denominator? 4. Common mistake right there would be what? 2. Be careful. Multiplication, we multiply the numerators, we multiply the denominators. over here, square root of 3 times the square root of 2 is the square root of 6. 2 times 2 is 4. And that's it. That's your answer. That's the exact value. That's as simplified as you can get until you go to your calculator. Now listen, there's a couple different ways you could write this. So as for my quiz or like an FRQ, this is full credit, okay? But let me just show you other ways you could see it in the multiple choice. You could see it written as like one big fat fraction, like I call it, like the numerators share the denominator, because it's the same denominator. So that these two mean the same thing. And there's one more way, and that's factoring out the GCF of those numerators. The square root of 2 and the square root of 2 have a GCF of the square root of 2. Let me show you what I mean. I'm going to go off to the side and show it. If I factor out a square root of 2, I would divide these both by square root of 2. I would get 1 plus the square root of 3. So I just factored out the square root of 2, divided them both by the square root of 2. Square root of 2 divided by the square root of 2 is 1. And square root of 6 divided by the square root of 2 is the square root of 3. Now, what you're going to start seeing is you get a lot of answers that look exactly like this, where maybe one of them is negative because there might have been a subtraction in there or something. And think about why all of our answers are going to start looking the same, because there's only 3 different fractions on the whole unit circle besides the quadrantals, right? The whole unit circle exact values are 1/2 square root of 3 over 2 or square root of 2 over 2. And then we're just doing sine and cosine. We're not even doing anything with tan. There are some in different formulas for tan, but you'll get to those in calculus. But we just need those unless they put in a quadrantal where we have 1s, 0s, and negative 1s, you're going to get lots of square roots of 2s, square roots of 6s over 4s. Okay? Let's do another one. So here they want us to find the exact value of cosine of 7 pi over 12. They're saying 7 pi over 12 equals these two added together. And I could do a common denominator again of 12 and show you that when you add these together, you would get a numerator that adds up to 7 pi and a denominator of 12. So I'm going to call this alpha and that beta. Now think ahead for a second. When we get to the homework, I'll do one with you because there isn't any in the notes. When we get to the homework, there's a couple problems where they don't even give you that. They just say, find this, find that. And you have to come up with 2 angles on your own that either add or subtract to get 7 pi over 12. And I'll show you how to do that. It's not hard. But it involves being able to get common denominators and stuff. And then you just pick what 2 angles you want to use. And there's more than one way of getting any of these, but I'll teach you the easiest way. So I'll come back to that. But right now, they're giving us the alpha and the beta. So right now, I have cosine of, I know it's cosine, so that, pi over 4 plus pi over 3. That's what they gave me. So this is my alpha, that's my beta, and now I'm going to expand it. So try not to look up at the top. Let's try to remember the pattern. Always start with the very first thing you see. So it's cosine of pi over 4. And cosine is not social. It doesn't start with an S. Cosine is not social. So we're going to keep cosine with cosine. And we already used pi over 4, so we're going to use pi over 3. And then cosine starts with a C, so that means we're going to change the sign for our negative. And now we're going to do sine, sine. And we always keep alpha and beta in the same order, so it's sine of pi over 4 times sine of pi over 3, right? Alpha, beta, alpha, beta, alpha, beta. And then unit circle. Square root of 2 over 2. 1/2. Square root of 2 over 2. And square root of 3 over 2. Told you, look, all those same numbers we just saw in the last problem. We would get square root of 2 over 4 minus square root of 6 over 4. And then you saw the other 2 ways you could write it, but this is perfectly fine. So I showed you all 3 different ways. This is perfectly fine, or one of the other 2 ways. So you start seeing a lot of the same answers. And just so you know, guys, when you start doing this on your own, it wouldn't have mattered if you put pi over 3 first and pi over 4 second. Order of addition doesn't matter, right? So in this problem, your answer would have been the same. So you do this on your own. You decide to put pi over 3 first. You're not wrong. It doesn't matter. The difference in your answer would have been this. The negative square root of 6 would have come first, and then the square root of 2, being positive still, over 4. So it means the same thing. So don't, when you get to the homework, I had people like, wait, I have the positive one first. It doesn't matter, okay? It doesn't matter as long as the square root of 6 is negative and the square root of 2 is positive, okay? We have one more example, and that's a proof. What we've been doing for the last few days is verification problems, proving that one side equals the other side. And that has not changed. Okay? That has not changed. We're still doing that. Yesterday, so Monday, the feedback I got was, you guys thought Monday was pretty easy. Yesterday was really hard, okay? Today, proofs, really easy, okay? Here's the good thing. When you get a proof that you have to do, and one of the sides has sine or cosine with a plus or minus, when it has one of these on it, life is good. Because when you see this, you're just going to expand it using that, and you're going to see things start miraculously canceling, okay? So in this problem, I see, oh, I'm going to work with the left-hand side, and I'm going to prove that this can equal this, showing all my steps. So the first thing I notice is there's a sign with a subtraction. And you say, yay, this is going to be easier than the ones she made us do the other day. So remember, alpha and beta are always in that order. Let's try to use the formula without looking at it. We always start with what we see. In this case, it's sine of pi over 2. And sine is social, so I'll use cosine, and then beta. Remember, it's always in that order, alpha, beta. In the problem, as we expand it. For sine, we keep the same sign. So since there was a subtraction here, we keep a subtraction sign. And then we start with cosine pi over 2 sine of x. You should have no duplicates, right? There shouldn't be 2 cosine of x's or 2 cosines of pi over 2. Every single one of these should be different. Okay, somehow we're going to prove that this equals cosine x. So let's just, remember, you do one thing. I knew how to expand that. Now, looking at this, oh, I can simplify this and this. I know that pi over 2, Evan, what's my ordered pair at pi over 2? Take your time, doesn't have to be fast. Yes, 0, 1, right? So cosine sine. So sine of pi over 2 is 1. I don't know what x is, so I can't answer that. Minus cosine of pi over 2 is 0. I don't know what x is, so I can't do sine of x. So fill in what you can, and then things are going to start miraculously canceling, like I said. So 1 times cosine x is just cosine x, right? Minus 0 times anything is 0. Cosine x minus 0, cosine x. And that's what we were trying to prove. So those are usually really easy. And guys, think about on the quiz. I know it's an open note quiz. So what you have in your notes is this. So nobody should be making any mistakes on their trig on this open note quiz because you're allowed to use your unit circle. I don't like it, but there's no way for me to take them away from you. I would just say, please don't depend on your unit circle through the homework. See if you can come up with it first, then check your answer. You don't want to start depending on this again because you're not going to have it for any other test or exam, okay? All right. Ready for homework? Let's go to page 152. Is that right? Guys, somebody tell me. I messed up last one. Page 152. This is D3. You're doing 1 through 11, omit number 4. Omit means don't do. Guys, cross through it, but leave some space there because when I do number 7 with you, I want to have you guys put something here to help you with some other problems, okay? So 1 through 11, omit number 4. D3. I'm going to do number 1 and number 7 with you. You guys are going to get this done in class with plenty of time, so don't feel rushed. Pay attention when I go over these assignments. This problem. I'm actually doing 1 and 7 with you because there were none like that in the notes exactly like that. All right, so look at 1, 2, and 3. Notice it's already expanded for you. What we're doing with 1, 2, and 3 is working in reverse. Kind of like when you get an expanded log and you had to condense it to a single log. That's what's happening here. We're working in reverse. In other words, this is alpha, beta, alpha, beta. It's a sign problem with a plus in it. So that means this is actually sine of alpha, and sine is same, so I put a plus sign there, beta. Let's go further. We're trying to find the exact value. So sine, I'm going to actually add those together. 1 pi plus 5 pi is 6 pi. And guys, we don't know what 6 pi over 18 is. We shouldn't, because we haven't simplified it yet. 6 and 18 are both divisible by 6. 6 goes into 6 once. 6 goes into 18 3 times. And now you're just going to answer the question. What is sine of pi over 3? That's the one up by the y-axis. It's the second number in that ordered pair. This would be your final answer. We're just working in reverse. That's what you're doing with 1, 2, and 3. 5 and 6 are just like the notes. You put alpha, you put beta, you expand it. But don't work on those. Do number 7 with me. This is the only one, this is the first, there's 2 of them, where you have to come up with your own 2 angles. Guys, listen. Listen. You can use any 2 angles on the unit circle, but they have to either add or subtract to get 5 pi over 12. And even though you're allowed to use any quadrant, which quadrant is the easiest quadrant to work with? 1, obviously. We know the most about quadrant 1. Remember I said I was going to have you show some work here? This is going to help you with 7 and 8. But think about on the quiz, you can have any denominator, okay? This is what you would need to do. If you like quadrant 1, which I would recommend, I would just find a little workspace and find out what your denominators would be if they were 12. Because remember, you have to come up with something that adds or subtracts to get 5 pi over 12, and then when you do number 8 on your own, 1 pi over 12, okay? So do your common denominator business. This is times 2, that's times 2, times 3, times 3, times 4, times 4, okay? So what I did is I took my quadrant 1 angles, gave them a common denominator of 12, and now I just find a combination where I either add or subtract to get 5, okay? So clearly, these 2 add to get 5 pi over 12. So I'm going to use pi over 6 and pi over 4. It doesn't matter which one you put first. It's addition, right? So it doesn't matter. We had a 5 pi over 12 in our notes, and the way it was written was pi over 6 came first. I'm going to put pi over 4 first just to show you it doesn't matter, okay? So I'm going to rewrite this as cosine of, what did I say? It's going to pi over 4 plus pi over 6. Does everybody know where I got those 2 and why? We're good? Ask a question if not. Right. So the order I wrote these in, that would make this alpha and this beta. Now I'm going to expand it. You always start with first thing you see. So it's cosine of pi over 4. Cosine is not social. He likes to only hang out with other cosines. And then we would put our beta. Cosine starts with C, so does change. So instead of plus, I'll put minus. Now I do the signs. We always keep alpha and beta in the same, multiplication, in the same order. Alpha, beta, alpha, beta. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 6, remember 6 is the one close to the x-axis. That would be square root of 3 over 2. Pi over 4. And sine of pi over 6. So you can see by using quadrant 1, I don't have any negatives. So when I get to pick the angles, I always try to use quadrant 1. I know those really fast, too, and I don't have to write off negatives. And then you know how to do this last step, I think. Put it all together. Square root of 6 over 4 minus square root of 2 over 4. Remember, the numerators could be reversed. As long as the square root of 2 is negative and the square root of 6 is positive, that's fine. You could write it the other two ways I showed you. But this is perfectly fine. Okay? So that's how you're going to do number 8. So guys, look at number 8 real quick. 1 pi over 12. You could subtract these two, or you could subtract these two. You and your neighbor could do two different angles, and you should get the same answer. So you could subtract these two or subtract these two, because you want to get 1 over 12, right? 1 over 12. So this minus this, or this minus this. So this minus this, or this minus this. The order would matter with subtraction, right? Subtraction matters. I am here for you. Work together, ask me for help, you know the drill. Do any of you not have a first period? Anybody not have a first period? Just you, Raja? Okay, you know there's a mental health lesson on Fridays, your fall schedule is different. I just want to tell you Friday, second to 12 on Friday, just let you know. I know nobody tells you this stuff.